Hello everyone, this video is on the empirical formula, and what the empirical formula is it's experimentally determined. So, and it shows the lowest ratio of elements in this compound. So say you found some random substance and you ran it through, and you would find, you don't know its true formula, but you do know the empirical formula, what is in it and what the ratio is. And so you can so you can compare it by comparing formula masses of the empirical to the norm formula mass. You can find the real formula, or the molecular formula, or the true formula. So an example is like glucose. So the formula of glucose, its real formula, its molecular formula, C6H12O6. That is, if you find glucose, this is its formula. But say you could only get if you were getting the empirical formula of glucose, you would get CH2O, because that's the ratio, that's the lowest ratio glucose is. For every carbon, there's 2 hydrogens, 1 oxygen. It's not its true formula, but that's the ratio. And so, kind of just to start, an example of, say, the empirical is, say you had 1.67 grams CE, and then you had 4.45 grams of iodine, and you were asked to find the empirical form. So again, more dimensional analysis. You start with your given. I'm going to start with CE, and then you're going to convert it to moles. And then, of course, when you're converting by moles, you put it over its, you would just, since you're just doing elements, you put it over its mass on the periodic table. In this case, 40 point, oh no, that's not that one, 140.12. And then you multiply, and don't worry about sig figs for these. Just write down like 7, 6, 5, 6, 7, a bunch. Just write down a bunch of digits. Like I'm gonna write. Okay, so now I'm gonna do the same thing for iodine. Put it over its mass from the periodic table. And this is 0.0. Okay, so now what you are going to do is you're going to take the smaller of these 2 or 3, 4, 5 numbers, and you are going to divide all of them by the smallest one. So CE is the smallest. I'm going to divide by this, which gives me exactly 1. And then I'm also going to divide by this, which is going to give me approximately 3. Now, when you say approximately on these, it has to be extremely close or exact. It has to be 2.99. You call that 3. 3.00 blank, 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 blank. That can be 3. It has to be extremely close. So now I know I have this ratio of these is for every 1 CE, I have 3 iodine. And that would be the empirical formula from this example. So you can also do it with percents. If it's a percent, you just assume you have 100 grams, and you just change that percent sign to grams and do the same thing. So kind of the step for these, if you're given 2 masses, 2%, just convert everything to moles. And then divide everything, that thing you got, divide the mole you got when you converted by the smallest value. Okay, so now say you have the empirical formula, and in this question it gives you the empirical formula and it gives you the formula mass. So now you are able to find the true molecular formula of this compound. So say the empirical formula was mercury CO2 and then say it gave you formula mass of 304 atomic mass units. So there's 4 steps. The first step is to calculate the empirical formula. So if it didn't give it to you and say it gave it to you like this, it said, we have blank amount of mercury and blank amount of CO2, you would need to calculate that empirical formula and get it. Well, we already have it because the problem was nice and it gave it to us. So next what we have to do is find what you can call the empirical mass, which is basically just going to be the formula mass of this. And the empirical mass of this compound is 151.88. So our third step is going to be to compare the molecular and empirical masses. And molecular can also mean formula, same thing. So we know we have 304 and then 151.88. Okay, so then you are going to put that in the calculator and divide, and you get approximately 2. So then you divide, and then the fourth step is to multiply your empirical formula by the quotient of the comparison. Okay, so since we got about 2 for this, we're going to take our formula, which was HgCO2, and that H was actually an A the whole time. Silver. That is very silly. I cannot read my own handwriting, which is probably no surprise to you all, since you have seen that my handwriting can get. Okay, that is an A. Okay, it's silver. Okay, but I mean, everything should be correct, but all you're going to do is you're going to take that and you're going to multiply it by 2, use distribution, and so the true molecular formula of this is AgC2O4, just like that, and that is the molecular formula. So yeah, it's that's about it for empirical. It uses a lot of the molar conversions to do this. You need moles to maybe not to do these conversions, but you need it to get your empirical formula in the first place. So yeah, if you're good on moles, I think this should be pretty easy to figure out. So thank you so much for watching, and sorry for all my mistakes. Just a reminder, I'm holding a Zoom review session December 12th at 2 p.m. Just come, talk, text, email, call, I don't know, contact me in some way, and I will give you the link. I just don't want the link out on YouTube, you know. But I will give it to anyone, and feel free to send it to friends or anything who want to come. I'll also record it, and then I'll send it to everyone there. So if you know someone who missed it and would maybe benefit from it, you can send it to them. Yeah, that's about it. Thank you so much.